to the chapter 4 review questions. As normal, I am not going to do number 1 because it's just terms and definitions, and you can do that on your own. Question number 2 says, what do we call the current model of the atom? And so this chapter, we get introduced to this very complicated drawing, and I'm not going to try to draw it, of an atom. And we have a name for this, and we call it the quantum mechanical model. This is that model that has that very complicated picture, but it talks about an electron having a wave, like a wave or a particle properties. It has both. Question 3 says, what do we call the type of wave interference when we have two waves and when they add together, the crests get taller and the troughs get deeper? And so that's when you have two waves and they line up just perfectly so that when you were to take these and add them together, you would get one bigger wave with higher crests and lower troughs. And this is adding together to make something bigger. And when waves add together, this is called, like this, it is called constructive interference. Question 4 says, what's the opposite of constructive interference? And it happens when waves that add together like this and they cancel each other out. And instead of being constructive and building something, they're destroying something. And so we call that destructive interference. Question 5 says, to come up with the current model of an atom, Edwin Schrödinger analyzed electrons as if they were waves. And he's the guy that looked at how waves added to make constructive and destructive interference. Question 6 wants you to list what types of orbitals are available in the third energy level of an atom and how many of those orbitals exist. So the first, second, and third is what I've written. And if you'll remember, in the lowest energy level, the 1, there's only the S. There's only the S orbital in the first energy level. Now, in the second energy level, as we work across, you add on from the S, you add also the P's. And then at the third energy level, we have the S, you have the P's, and if you'll remember the third energy level, you also add the D. Now, in each orbital can only hold 2 electrons, and so in the third energy level, there is one S electron, right? So like these two. And in the P, since there's a total of 6 electrons and each orbital can only hold 2, there's 3 P options. And in the D, since D has 10, if you were to count this across, that would be 10, you have 2 electrons in each orbital. 10 divided by 2 is 5. So you have a total of 5 D orbitals in the third energy level. So the energy levels that are available are the S, P's, and D's. And you have 1 S, 3 P's, and 5 of the D. Question 7 says, how many electrons can each orbital hold? Each orbital holds a pair or 2 total electrons in each orbital. Question 8 gives you a drawing of 4 orbitals, and it asks which one of these is a 2p orbital and which one is the 3p orbital. Well, A is a circle, it's a sphere, so this is just an S orbital, and the same is the case for C. It is the S orbital. The dumbbell is what they consider this shape. This is the P orbital. This will be the smaller orbital based on the size. So this is the 2p orbital. And then since D is bigger, it will be your 3p orbital. Question 9, and I'm going to just add the picture next to me. And it's telling me sunlight from a pinhole is shined on 2 slits that are very closely spaced. Which of the following is the result? And this is from Young's experiment, and you can read about it in the text. The pattern that is seen as the result of this experiment is B. Question 10 is using that same picture from 9, but instead of having light, it says what would happen if we used electrons to go through the slits. Well, if you'll remember, electrons act like a wave, just like a light wave, so you would have the same pattern come through the slits as you did with a light wave. Question 11, you're going to get a lot of practice with electron configurations. This is going to be one of those review questions that has lots of questions with multiple parts. So even though you see it and you think you'll have 26 questions, that's a little deceiving. But we're going to write ground state electron configuration for nitrogen. So nitrogen is up over here in my nonmetals on my periodic table. And we're going to start, though, at the top corner. And remember, this first energy level is the 1s, and I'm going to fill on across. I go 1s2. Now the next one, there's not a row up there, so it comes down here and I say 2s, 1, 2. And I get up here to nitrogen, and so I'm on 2p, 1, 2, 3. Second energy level, p orbital, and there are 3 electrons in it. The next one we're going to do is aluminum, which is all the way down here. So just like we did with nitrogen, we're going to start with the 1, and we're going to fill in the first 2 s orbitals. Then the next one, you have the second energy level, and in the second energy level, you have s orbitals, but you also have p orbitals in the second energy level. But for aluminum, we're going to fill all those p's. So there's 6 of them. And we're going to come to the third energy level where you have 3s2. And we're going to be on our third energy level, but this is p, and this is the first p of the third energy level. And so this would be the electron configuration for aluminum. Next one we're going to be looking through is magnesium. It's right down here on the third row. So we're going to start again though with 1s2, go down to the second row to 2s2, keep going across the second row, you have 2p6. After 2p6, we're on 3s, and we're stopping at magnesium, so it's 3s2. And the very last one, I wrote bromide, but it's bromine. It's all the way down here, so it's going to be a long one. We can do it. So 1s2, as is normal, to start. 2s2. Then across to 2p6. Then back over here to 3s2. Keep going across, 3p6. Four s2. Remember, when you hit this first row of D's, you drop. So instead of saying 4, we say 3, and we're going to go across all 10 of these. So 3d10. And the last level we have 1, 2, 3, 4, 5. So it's fourth energy level because it's the fourth row, P5. 4. That's the electron configurations for all 4 parts of 11. Question 12 wants you to give an electron configuration, but it's asking you for the abbreviated electron state for iodine. And so iodine is down here. And so if you'll remember to do the abbreviation, you go to the previous noble gas. So for iodine, it would be krypton. It's going to be a little confusing because I don't have all my periodic table up here, but you're going to write krypton in brackets. So we're basically starting our configuration at krypton. Then the next row we would start with is 5, and it's S2. Now I don't have my numbers, but just envision they go all the way across here. And so this is the D, so you drop down a level, so you say 4D, and I've got all 10 of those. And then we pick back up over here with 5, go back up to 5. These are P's. So envision there's 1, 2, 3, 4, 5. So 5P5. And so this is considered the abbreviation since it starts off of the noble gas krypton. Question 13 has 3 parts. It gives you 3 electron configurations. And they're just asking you what is wrong. So you're looking for either a mistake in how many electrons are in the orbitals or in the order of the orbitals. So we're just going to see if we can follow this through and see what's the mistake in the first one. So 1s2, 2s2. So it goes 1s2, 2s2. But my next step would be 2p6. but they don't have 6, they have a 4. So the mistake is they put the wrong number of electrons there. For B, we go 1s2, 2s2. They got the 2p6 correct. Then I come here to 3s2. Then I go to 3p6. But what should come after 3p6 is 4s2. So this order is mixed up. Those are swapped on part B. Part C, we go 1s2. Then it says 2s4. Well, in s orbital, there's only one s orbital. Each orbital can hold 2. So this can only hold 2 electrons, not 4. Question number 14, if you have the first printing of your book, there is a mistake in this question. So you would either find these mistakes. There is an errata, which is a list of book mistakes on the Berean Builders website. There are not many, but this one is kind of a big one. So this is the corrected version. Your book, if it is like a second printing, it should be corrected in it. But question 14 asks you to figure out what element they're talking about. Now to do this, you could walk through every step of the periodic table, or we could simply look at the valence electron, which is these last here ones. And it is 4p2. So if I'm finding 4p, I go 1, 2, 3, 4, p, and it's 1, 2. So this electron, this is germanium, and it is a Ge. And if you're curious what the mistake are, these are all out of order if your book has the mistake in it. Question 15 says, what do we call group 8A on the periodic table? So this is this last row, and we call those the noble gases. They're named after the nobles because in medieval times, the nobles stayed in their castles and did not interact with the regular people very much. And so the noble gases do not react often. If you'll notice, they have 8 valence electrons and they're very stable. Question 16 gives you a list of elements and it asks you which ones have similar properties. So if you'll remember, the properties are a lot of times based on their valence electrons, and their valence electrons is also based on their column of the periodic table. So when it's asked for which ones have similar properties, you're going to be looking for elements that are on the same column of the periodic table. So if I were to find all my choices, I don't have it on my periodic table, but below gallium here, you would have In. And so you have aluminum, Al, and then you have In, and these are in the same column. So they have the same valence electrons, and therefore they have similar properties. Question number 17 tells you to draw the Lewis structure for oxygen. So you're going to start with the chemical symbol, which for oxygen is an O, and it's all the way over here. So it is in the 6th column, so it has 6 valence electrons. So you're just going to draw in your 6. Remember, you put the first 4, and then you go back and pair them up. So this would be the Lewis structure for oxygen. So question number 18 says to draw the Lewis structure for the ion that oxygen forms and name it. So when oxygen forms an ion, it's actually wanting to gain 2 electrons. So it becomes 2 negative because it gains 2 electrons, which is why we write it oxygen and we put the 2 negative. But if we're going to name this, it would be the oxide ion. Question number 19 asks you to draw for potassium the ion that it would form and name it. So you should learn that potassium's chemical symbol, K. And potassium has 1 valence electron because it's in the 1 column. And it's actually going to give away its valence electron. So when it loses a negative electron, it has a positive charge. So this is how we would write the formula. But its name is the potassium ion. Question 20 tells you to name 3 properties of metals and the properties of nonmetals that go with it. Well, metals, we consider metals to be malleable, which means you can bend them. But nonmetals are brittle. Like if you try to bend a nonmetal, it's not going to bend like a piece of aluminum foil. It's going to break. Metals have luster, which luster is just shine. and nonmetals are not very shiny. Metals also conduct electricity and heat very well, and nonmetals will conduct some electricity or heat. They just don't do a very good job of it. Question 21 has 4 parts. I'm gonna do 2 parts at a time, and it gives you 2 elements, and it asks you to write the formula for the compound it would form when it makes an ionic compound. So ionic compound, remember, we have a metal and a non-metal. Metal's the first, non-metal's the second, and the metal is giving away electrons to the non-metal. So we have rubidium, which is down here, and it is in the group 1. And so it has 1 plus charge, which means it's giving away 1 electron. And we have oxygen, and it's over there, and it is in the column for 2 negative when it makes an ion, which means it's taking in 2. Now, if you'll remember, we can crisscross the charges so that we can write the formula. So you would bring the 2 over here, and you could write the 1, but it's usually left out. And so this would give us 2 rubidiums. Each rubidium is giving away 1 electron, and then 1 oxygen is taking both of those electrons. So if you wrote the formula, you would simply write. So for the second set of elements, they give you strontium, which is right here, and sulfur down there. So strontium is a positive 2, which means it's going to give away 2 electrons. And sulfur is down here, and it is a 2 negative, which means it is going to be taking in 2 electrons. And so these are actually balanced out. We don't need to do the crisscross. One's giving 2, one's taking 2. So the formula would just be SRS. For the last 2 for question 21, we have calcium and nitrogen. So calcium is a group 2. So it is a charge of 2 positive because it's giving away 2 electrons. And nitrogen is in group 5, which means it has 5 valence electrons. So to have 8, it wants 3. So we say it becomes a negative 3 charge. And so for nitrogen, you're going to put an N and you're going to put a 3 negative. Now, these do not balance out, so you're going to have to cross the charges here. And what this will do is this gives me 3 calciums. Each calcium is giving away 6 electrons, or each calcium is giving away 2 electrons. So total calcium is giving 6 electrons away. And I have 2 nitrogens, and each nitrogen is accepting 3 electrons, so they're accepting 6 electrons. And so the formula, you would simply write Ca3N2. All right, the last formula we're going to write is magnesium and iodine. So magnesium is in your group 2, which means it is giving away 2 electrons. So it's a 2 plus. And iodine's all the way over here in group 7A, which means it has 7 valence electrons, so it wants 1 more. So it's going to gain an electron, which gives it a 1 minus charge. Now, if magnesium is giving away 2 and iodine is only gaining 1, it's going to take 2 iodines to gain those 2 electrons. And so you could do the cross method and you would have magnesium 1, iodine 2, but you don't have to write the 1. 22, we're doing the same thing. We're writing another formula. So we have calcium and we have fluoride. So calcium here is in a group 2. So it has 2 valence electrons that it gives away. And you're going to find fluorine all the way over here in group 7, which means it needs 1 more electron. So we're going to say it takes in 1 electron. Now, if fluorine takes 1 and calcium's giving 2, it's going to take 2 fluorines. You're going to cross your charges. And it is calcium CaF2. And the reason is this calcium is giving away 2, and each fluorine is accepting 1 of them. Question 23 says nitrogen and hydrogen react to make a compound. Is it an ionic compound? If you remember, an ionic compound has to be between a metal to give away electrons and a non-metal to accept electrons. And nitrogen is up here in the nonmetals. Hydrogen is considered a nonmetal. So even though hydrogen is on this side of my periodic table, it is purple. It doesn't follow all the rules of this one, so it is a nonmetal. So both of these are nonmetals, so this is not an ionic compound. Question 24 has us writing another chemical formula, but if you'll notice, this one has parentheses and the number 3 in it, or the Roman numerals for 3. So when we have parentheses, we know that it is for a transition metal, or a metal that it is charged can change. And so this tells me the charge. And so iron is Fe, and it is a 3+ charge. I know that because of the 3 there. I know it's plus because it is a metal, and metals become positive. They give away their electrons. Then the oxide part, or the oxygen, I know that oxygen gains 2 electrons, so it is a 2-. Now to write this formula, you're going to swap your charges. So you have 2 irons and you have 3 oxygens. And what this means is you have 2 irons. Each iron is going to be giving away 3 electrons. So that's a total of 6 electrons getting pushed away from the iron. And you have 3 oxygens, but each of those 3 oxygens is taking 2 electrons. So that's a total of 6 electrons going to the oxygens. So you want to make sure if you're giving away 6 electrons, you're taking in 6 electrons also. 25 wants us to write the name for CrCl3. So if I look at chromium and I see it on my periodic table in the transition metals, I know that I'm going to have to, when I write my name, use parentheses for the charge because I don't know it can change. So I have to first figure out what that is. So chlorine has a charge. It's down here. It has 7 valence electrons, so it's wanting 1 more valence electron. So if chlorine is a 1 negative charge, and I'm not sure what chromium is. Now I have 3 chlorines, so I'm having a total of 3 electrons, a 3 negative charge, which means 3 electrons going into chlorine, right? 3 chlorine atoms, each one is getting 1 electron. So chromium must be giving away 3 electrons. And for that to happen, the charge on chromium must be a 3. I'm not going to mess with the subscript here because that would be changing the compound, and they gave me the compound. So when you write this, you have to put the 3 in parentheses when you have a transition metal. And so you write the name of the metal, you put the charge, and you write the non-metal, and you change the ending to IDE. Question 6 gives you 4 compounds. Some of these compounds have lots of elements to it, and we haven't really talked about those. But ask which one of these will not conduct electricity. You should know that the ones that conduct electricity are going to contain a metal. So you're going to be looking for metals, and you can know that's going to conduct electricity. So NaCl, Na is sodium, and it is a metal, so this one's going to conduct electricity. K is a potassium, and it's a metal, so it's going to conduct electricity. Carbon, hydrogen, and oxygen. Carbon, oxygen, and this weird hydrogen up here are all nonmetals, so this compound is not going to conduct electricity. And when you come down here, rubidium, it is a metal, so it is going to conduct electricity. So the only one that does not have a metal in it is C6H12O6. All right, great job on the chapter 4 review questions. I would tell you to focus on naming those compounds and writing those formulas. And if you didn't get extra practice with that, there are some other YouTube videos that you could find for help, but you need to make sure that you understand how to do the charges on those formulas and names.